In this video, I want to show you how you can use the standard normal table to find a value when you've been given a proportion for a normal distribution problem. In this problem, a soft drink machine is regulated so that it dispenses an average of 200 milliliters per cup. And the distribution is normally distributed with a standard deviation of 15 milliliters. So if we draw our distribution, we're going to center it at our mean, draw one standard deviation up, 2 up, and 3 up from the mean, 1 down, 2 down, and 3 down from the mean. And we can start then with our first problem. Only 2% of drinks dispensed will have less than what amount of liquid per cup? Well, we want to find the value that cuts off the lower 2% of our data. Now, I put it here because I can approximate where that value will be according to the 68, 95, 99.7 rule. I know that about 2.5% of my data will fall below 170. So a little bit lower than that should be about the 2% cutoff. And so I can kind of visualize what that value will be. So the first step is we have to remember the formula in finding this value. It is x will be equal to our mean plus sigma times z, where z is the value in which 2% of our data will fall below in the standard normal distribution. So we want to find the probability that z is less than some mystery z, which is equal to 0.02. So we need to find this z-score essentially. So z will be equal to something in which the area that falls below that is 0.02. So if we go over to the standard normal table, we want to find the area in these values that's 0.02. So if we start looking across here, we see that all these values are pretty small, so we should scroll down until we at least see 0.02, and here I do. I'm going to go across this row, and I notice that 0.02018 then goes to 0.01970. This means that 0.02 is somewhere between these two values. So my z-score is negative 2.0 with a hundredths place of 0.05 or 0.06, or somewhere in between there. So I'm going to call this negative 2.055. Negative 2.055 is then the z-score in which about 2% of my data falls below that. Now I can simply just plug this into the formula. So x is equal to 200 plus sigma of 15 times my z-score of negative 2.055. This will give me a value of negative 30.825 plus 200. Now remember, when I add a negative, it's the same as just subtracting that value. So this is equal to 169.175. So that is the amount of drink in which only 2% of the cups dispensed will be less than. This seems to make sense according to where we drew it on our distribution. So it seems like a pretty good answer for this. All right, so for the next problem, we want to find the area or the value in which 5% of the area falls above. So in the problem it reads, 5% of drinks dispensed will have more than what amount of liquid per cup? So we're looking for that top 5%. Let's go ahead and draw that in. Be about here. Again, we know that above 230 is about 2.5%, so a little bit more than that will be, or a little bit less than that on our distribution will be about 5% above that. And so it should be somewhere between 215 and 230. The way that we should think about this too is this is also the value that cuts off the lower 95% of our data. So when we find our z, we want to find the probability that z is greater than some z value is going to be equal to 0.05. Well, this is equivalent to the probability that z is less than some mystery value is equal to 0.95. So we want to find this z-score here in which 95% of the data falls below. So if we go over to our z-table, we want to find then in these proportions the value 0.95. And I know that this is going to be a positive value, so I'm going to keep scrolling through. And I notice that I went a little too fast, that here, start at 0.945 and keep going across. I see that 0.94950 goes to 0.95053. And so my z-score will fall somewhere between 1.64 and 1.65. So I'm going to say this is 1.645 just to approximate it. 1.645. Now I just simply plug that into the formula. X is equal to my mean of 200 plus the standard deviation of 15 times 1.645. This expression then comes out to be 24.675. Add on 200, and I get X to be 224.675. So only 5% of drinks will have more than 224.67 milliliters of liquid. In this video, I'd like to show you how you can use the central limit theorem and the TI84 to solve this problem. So suppose the average time spent exercising per day in minutes for all OSU students has a mean of 28 and a standard deviation of 19. This means that the mean is equal to 28 minutes and the standard deviation is equal to 19 minutes. What is the probability that a sample mean from a sample of size 150 would exceed 30 minutes? So here's the deal, is that now we're talking about a sample mean from a sample size of 150, which means that we no longer are talking about the population distribution. We're talking about the distribution of sample means. So for a sample size of 150, that means that the mean of our sampling distribution is still going to be equal to mu. This is equal to 28 by the central limit theorem. But our standard deviation, or sometimes called the standard error, sigma x bar, will be equal to 19 over my sample size of 150, which in this case is equal to 1.55. So now this is my standard deviation for my sampling distribution of x bar. So to rephrase this, x bar has a mean of 28 and a standard deviation of 1.55. Now if we want to find the probability that x bar is greater than 30, we can simply just either find the z-score for this, or when we're using the TI84, we just use the inverse norm command. So we can go to second, distribution, scroll down to normal CDF, and here we want to put in our lower bound, that'll be 30. The upper bound will be infinity. Again, this is 1 second EE to the 99. That'll be a really big value. Our mean is 28, and then the standard deviation is not 19. That's the standard deviation of the population. The standard deviation of x bar is 19 over the square root of 150, our sample size, which is 1.55. Enter in this, press enter, and we get a value of 0.0985.